Bismillahirrahmanirrahim. SSC 1 New Syllabus Physics SSC 1 Unit 1 Physical Quantities and Measurements. Exercise 1 Numerical Problems 1.6 to 1.10. In previous video we can solve 1.1 to 1.5. In this video we can solve 1.6 to 1.10. So in 1.6, on closing the jaw of vernier caliper, zero error of vernier scale is on the right to the main scale, such that fourth division of its vernier scale coinciding with one of the main scale divisions. Find its zero error and zero correction. This question solved by two methods. Both methods are correct. First, we see the first method. In first method, we can find the solution. Vernier division coinciding with the main scale is equal to fourth division, and least count of vernier caliper is equal to 0.01 centimeter. Zero error is equal to 4 multiplied by 0.01 centimeter is equal to plus 0.04 centimeter. Now the zero fraction is equal to minus 0.04 centimeter. Solved by other method, given data, number of division denoted by small n. So number of division n is equal to 4 and least count is equal to 0.01 centimeter. Main scale reading 0.00 centimeter to find zero error and zero correction. Then using the formula, zero error is equal to main scale reading plus vernier scale reading. Now main scale reading is equal to 0.00 centimeter. Then vernier scale reading is equal to least count multiplied by number of division. Then L dot C least count multiplied by n number of division is equal to 0.01 multiplied by 4 is equal to 0.04 centimeter. The zero error of vernier scale is right side of the main scale, 0. So the zero error is positive, then we have zero error is equal to positive into main scale reading plus vernier scale reading. Main scale reading is 0.00 centimeter plus vernier scale reading is equal to 0.04 centimeter. Then final answer zero error is equal to plus 0.04 centimeter. Note, if zero error is positive, then the zero correction will be negative, and it is a vice versa. Here zero error is positive, then zero correction is negative minus 0.04 centimeter. Result, zero error is equal to plus 0.04 meter and zero correction is equal to minus 0.04 centimeter. Similarly, we can solve 1.7 of degree gauge has 50 division on circular scale. The pitch of degree gauge is 0.5 millimeter. What is its least count? So, given data, total number of division on circular scale is 50 division and pitch of degree gauge is 0.5 millimeter. To find least count of degree gauge, we can use the formula least count is equal to pitch divided by number of divisions on circular scale. Solution, as we know that least count is equal to 0.5 millimeter divided by 50. The answer is 0.01 millimeter. So, in above equation, the least count is equal to 0.01 millimeter, or we can convert into centimeter, then it will be equal to 0.001 centimeter. Thus, the least count of segregation is 0.01 millimeter or 0.001 centimeter. Third, the least count of segregation is 0.01 millimeter. In next question 1.8, which of the following quantities has three significant figures? So, given that four parts. In first part, we can see that is 3.0066 meter. There are 1, 2, 3, 4, 5 digits. So, there are 5 significant digits in this measurement. In B part, we can see that 0.00309. So 309 is a significant digit. So we can write that there are three significant digits in this measurement. In C part, 5.05 multiplied by 10 raised to power minus 27 kg. Here 5.05, three digits, so we can write that there are three significant digits in this measurement. And in last part 301.0, 1, 2, 3, 4. So there are four significant digits in this measurement. Now result in B and C part. There are three significant figures. Now we can move from 1.9. There are significant figures in each of the following measurements. Here four parts are given. We can write and explain each part. First of all, we solve the first part. A part 1.009. We know that as non-zero digits are always significant digits. 1 and 9 are significant digits. So, similarly, 0 between the two significant figures is also significant. Here we can see that the total number of significant figures in this measurement are 4. We can write the part B. We can see that 0.00450 kg. Or non-zero digits are always significant digits. 4 and 5 are significant digits. The 0 on the left side are not significant digits. So there are 3 zeros on the left side are not significant digits. The result, total number of significant figures in this measurement is 3. Now we can solve C part. We can see 1.66 multiplied by 10 raised to power minus 27. Similarly, we can know that as non-zero digits is always significant. So 1 and 6 are significant and the digits in power of 10 are not considered as a significant digit because 10 raised to power minus 27 is non-significant in this case. So we can write that the result total number of significant measurements are 3. In last part 301.0, we can see that are non-zero digits in always significant. 2 and 1 are significant and second 0 between the two significant figures are also significant. So 0 between the 2 and 1 are significant. The total number of significant figures in this measurement are 4. Last question, question number 10. A chocolate wrapper is 6.7 centimeter long and 5.4 centimeter width. Calculate its area up to the reasonable number of significant figures. Now, given data, length is equal to L is equal to 6.7 centimeter and width denoted by W is equal to 5.4 centimeter. To find area, then formula area A is equal to length multiplied by width, L multiplied by W. So, in solution, As we know that area A is equal to L multiplied by W, putting the values in above formula, then A is equal to 6.7 multiplied by 5.4. Area A is equal to 36.18 centimeters square. Note as there are only two significant figures in this measurement of length and width, so the final answer of area or reasonable significant figure will be two significant figures. By rounding off, area A is equal to 36 centimeters square. Result, area up to reasonable significant figure is 36 centimeters square. Thank you for watching this video. Next video with next numerical. Allah Hafiz. Take care.